Hi, pre-calc students. We are going to look at 4 out of 5 of the problems on page 3 of the review. Okay, so we'll start with 28. So what we're doing is we're changing rates, right? We're basically going from radians in minutes to degrees per hour. So it says a Ferris wheel is rotating at a rate of 4.5 radians every 3 minutes. So I'm going to start out with that. And then I want to look at what our goal is. Our goal is to get it in degrees per hour. Okay. So I'm just going to change one unit at a time. And I usually start with the easy one, which is time. So we know that 1 hour is equal to 60 minutes, right? So I'm going to change the minutes. I'm going to put the minutes on top because I want minutes over minutes to cross off. So 60 minutes is equivalent to 1 hour. So really we just multiplied by 1 here because 60 minutes is the same as 1 hour. But now I can cross off those minutes and I'm left with the unit that I want, which is hours. Now I have to change to radians. So for radians, 1 full circle in radians is 2 pi. And that is equal to really 360 degrees, right? Because 1 full circle in degrees is 360. So if I put radians over degrees, and I'm talking 1 full circle over 1 full circle, that should be good. I have radians on the top over here, so I want radians on the bottom here. So I'm going to put 1 full circle of radians, which is 2 pi, and then I'm going to put 1 full circle of degrees on top. And then you can see radians over radians crosses off, and we are left with degrees on the top, hours on the bottom, which is what we want. We want degrees on the top, hours on the bottom. Well, now I have to calculate what that equals. I'm going to move that over a little bit. Actually, I'll erase this. Okay, I need a number. I've got the degrees per hour. I get the actual value by going 4.5 times 60 times 360. So on top, I get 97,200. In the denominator, I'm going to go 3 times 1 times 2 times 3.14. And I get approximately 18.84. And when I do 97,200 divided by 18.84, I get a number I can't fit in that box. I never should have boxed that in. Take that out. We can get rid of that. It is 5,159.2. Okay. All right. Now we'll leave it at that. Okay. Let's look at 29. I'm going to erase some of this here. So for 29, it says a wheel turns 400 revolutions per minute. So that's what we're starting at. 400 revolutions, those are full circles, per every 1 minute. The goal is to get it in radians per hour. So just like before, I'm going to change 1 hour to minutes. I see that minutes is in the bottom, so I'm going to put 60 minutes on top, 1 hour on the bottom, because once again, we want the minutes to cross off, and we want to be left with hours, because that's what we have at the end there. Now I need to change revolutions to radians. 1 full revolution, which is just 1 full circle, is equal to 2 pi radians. So because revolutions is on top, I'm going to keep it I'm going to put the revolutions on the bottom because I want it to cross off. 1 revolution is equal to 2 pi radians. But now revolutions over revolutions crosses off, and I'm left with radians, and that's what I want. Okay, so my numbers should be all set to go. I'm going to go 400 times 60 times 2 times 3.14. Now notice I just have a bunch of ones on the bottom, so I don't even need to divide that. I have 150,720 radians per hour. Okay, let's look at 31. So 31 and 32 get a little bit trickier just because we're changing between angular velocity and linear velocity. So that's always a little harder. But what we have to think about is circumference. So here it says a wheel with a diameter of 6 feet turns 140 revolutions per hour. So think, what is the starting rate? It's not that diameter of 6. It's 140 revolutions per 1 hour. What is the speed in feet per minute? So we want to get this to feet per minute. We'll say, yeah, that's our goal. Again, start with the easy one. 1 hour goes on top, 60 minutes goes on the bottom. Hours cross off, and I've got my minutes that I want at the end there. Now I have to change revolutions to feet. So again, you want to think circumference. If we go completely around a circle, and we're talking feet, that is the circumference. And remember, circumference is either 2 pi r, 2 pi times the radius, or diameter times pi. Well, they gave us the diameter in feet, and luckily we want feet. So remember, 1 full circle is a revolution, and that is equal to the circumference. And in this case, it is the diameter, which is 6 feet, times pi. So I'm going to put the revolution on the bottom because I want those to cross off. But 1 revolution is equal to 6 pi feet. All right, and now I have my feet and my feet. So now I can go ahead and multiply. 140 times 1 times 6 times pi gives me 2,637.6 divided by 1 times 60 times 1, which is 60. I divide the top divided by the bottom, and I get 44 feet per minute. So the trick here is whenever we're changing from degrees, revolutions, radians, to miles, centimeters, yards, we have to think circumference. Okay, now here we're doing the opposite. It says a point on the rim of a circle with a diameter of 3 inches moves at a speed of 800 feet per hour. So this time we're starting with linear, okay? And we're ending in radians per minute. I'm going to start again, you know, the easy one, 1 hour over 60 minutes. Eventually, you know, we get that one pretty well. Hours and hours crosses off, and I'm left with minutes. Okay, now another trick to this one is notice that the diameter is given in inches, and they started out with feet. So first we have to change feet to inches, and then we're going to change inches to radians. So first change feet to inches. So 1 foot is equal to 12 inches. So I'm going to put feet on the bottom. feet, foot, same thing. Just one is plural. 1 foot is equal to 12 inches. So again, basically I just multiplied by 1. 12 inches over 1 foot is the same as multiplying by 1. But now I'm left with inches. Okay, and that's going to help me because they gave me the diameter in inches. So I'm going to do diameter, which is 3 times pi. So diameter times pi, inches. That's the circumference of this one. It's 3 pi inches. And that's 1 revolution. Now I have to do the other one in radians. Okay, so kind of repeating that. This is 1 full circle is in terms of the circumference, diameter times pi. So the circumference is 3 pi inches. This is 1 full circle in radians. Okay, I'm going to have to move this down because I do not have room. I think it's going to be easier just to erase it. Radians per minute. Radians per minute was the goal. All right, but now I should be all set because I have inches over inches crosses off. I am left with radians per minute. So now I'm going to go back and I'm going to multiply the numbers. 800 times 1 times 12. Okay, now when I multiply the next thing, do you notice how I have pi over pi? I could go 800 times 1 times 12 times 2 times 3.14 and do the same thing on the bottom. But since we've got pi on the top and the bottom, I can also just cross that off. It doesn't matter either way. You can keep it and multiply it times 3.14 on the top and the bottom. Just saving ourselves a little bit of work there. 800 times 1 times 12 times 2 is 19,200. If I go 60 times 1, I guess this was 1 hour, 1 times 60 times 1 times 3, we get 180. And when we divide, we should get about 106.7 radians per minute. Remember what a radian is? It's those pi chunks. And there's a little bit over 6 pi chunks per circle. So it's like almost 107 of those pi chunks is how many angles it's passing through. All right, that's it for the review. Good luck on your test.